Good morning. All right, today this is a video lesson day. So all you have to do today is just take notes on the guided notes, which if you watch the video will have everything out. So today's learning objective is I can identify the domain and range of quadratic functions. So here we have a cannonball in medieval times getting thrown at some people, and what we have to do here is we have to recognize that this is a real life problem. Even though, a quadratic has negative and positives, we kind of don't, for a real world problem, we only focus on what is actually being affected when it comes to domain and range. So right here for the domain, we're only looking at, where we see the cannonball. So it's from here to here, right? It's not going to go back here in the negatives. That's not, the direction they're throwing this cannonball. And it's not going to go, further underground, right? So our domain is just there, right? That's our x. Now, what is, and it's also important in a real world problem to like identify in the real world context what that is, and that's the distance in horizontal, right? Horizontal distance. All right. And then we have our range. And the range is from the bottom to the top for the y. So, right? So the range is from the bottom, we don't go below, and then we don't go above. So when we look at this, we're going to say our domain is from 0 to 10, right? Because that's where it's positive. So here's 0 to 10. And we don't include this part because that part is like, it's not, it's not part of the real world experience. And then we're going to say the range is from 0 to 9. Now, a lot of times what we care about when it comes to quadratics is where it's increasing and where it's decreasing. So increasing just means that it's going from when we start here, it goes all the way up to the vertex, right, which is 4. So between 0 and 4, it's increasing, all right? And decreasing is where it's going down, and it's going down from 4 to 10. That's where it hits the ground, right? So that's all you have to do really for the problems for this week up until Wednesday. So right here, let's talk about this. What's the domain? If you said the domain is between 0 and 8, you were right, right? And for this problem, we're going to say that they give us the value for the x, so we're going to say that it's seconds. All right? What's the range? So you go to the y and you look here at 0 and all the way to the top, which I have to see what it's going by. So it's going by 50. I believe it's going by 10. So this would be 260. So I would write 0 y 260. And that's in feet. It's important to say to identify those things. Now, it's increasing from 0 to 4. And it's decreasing from 4 to 8. All right. Now we're going to look at a regions question. Which interval represents the range of the function h of x equals 2x squared minus 2x minus 4? So what you're going to do is you're going to take this function and you're going to put it in your calculator. And when you do that, you're going to get negative 4.5 is the vertex. So let me show you. Guard. All right. So as a reminder, we always go to Desmos. And we're going to go to our calculator. Two x squared negative 2x negative 4. 2x squared minus 2x minus 4. All right. We click on our key feature. So that's our vertex, right? And when we're looking for, and in the problem it said range. And so when we're looking at the range, it's from the bottom to the top. And because it keeps on going, we're going to use infinity. Now, we didn't really talk about this too much, but there's a thing called function notation. And all you have to know is when it's like a parentheses like that, it means does not include. When it's a bracket like this, that means include. Now, we're going to include negative 4.5 because it touches negative 4.5. We go back to the calculator. We see that this is on the graph, so it touches it. So we're going to include it. So the answer is going to be negative 4.5, include that, right? So it's 4 because that's the only option. But I want to explain why infinity has a parentheses, because you can never touch infinity. You can never get to infinity. That's the whole idea with infinity. It's unreachable. It goes on forever. So that's why every time you see function notation, it's always like that. Okay, this is a doozy of a problem. We're gonna read it, and you're gonna have to graph it and take a picture, but and then post the picture in your notes. But I don't get it's not a hard problem. Okay, so a football player attempts to kick a football over a goalpost. The path of the football can be modeled with the function, and I'm going to take a picture of this. Where x is the horizontal distance, so that's our domain, right, x, and h of x, our range, is the height of the football. Okay, so when both are measured in feet, so both are going to have feet as the value, okay? All right, so on the set of axes below, graph the function y equals h of x. So that's all, just saying that your output for the graph is going to be the y. Now this is a big one here. You get a lot of students get confused about when they see this. Over the interval, this is telling you the domain. So this is the domain. You're going to graph this thing from 0 to 150. That is what that is telling you. All right, so we go to our calculator, and we put this into our calculator. Anytime you see a fraction, I want you to do parentheses. So negative 1 over 2 to 5, close the parenthesis, arrow over, close the parentheses, x squared plus parentheses 2 divide by 3, close the arrow, close the parentheses, x. Now, we need to change it so our domain is from 0 to 150. I could use the zoom out button, but it's faster if you hit the graph settings button, go to x-axis, label it feet, right? It's in feet, and it's from 0 to 150. Y-axis is also feet because that's what they told us it was measured in feet, right? And I don't know what it is because they don't tell me what it is, but guessing from the question, we're going to try 0 to 50 because in the question it tells us that the goalpost is like 9. Oh, it looks like the vertex is actually above 20. So let's do 30. So in the question, all right, and then I say hit OK, and here it is. There it is. Now I want to capture it, so I'm going to zoom out just a little bit because I want to put this whole thing in there. Looks like the roots are 0 and 150, and the vertex is 75 and 25. So what I'm going to do is I'm going to go. I have a screen capture, so I'm going to go to screen capture, hit new, and I'm going to sketch, hit new, and then I'm going to start screen capturing it like this. Oop. Okay. Now, and I want to include there we go. And then just hit edit copy. Now, if you have an Apple, I believe just go online and look for screen capture. I believe it's like Shift and Control and 4, something like that. And what it does is you then screen capture, and it takes a picture of that and puts it on your desktop. You can screen capture anything on any device, even a Chrome. You just have to look it up. So you have to search it. And if you're having issues, you can contact me during office hours or anytime. But what I want to see is I want you to take a picture of this and put it into your guided notes. All right. Now let's get back to here. So we have the picture, right? And it asks us to determine the vertex. Well, we know the vertex, and interpret the meaning of the vertex in the context of the problem. So we're going to do this on a blank one. So I'm going to paste it here. So here it is, right? And what I'm going to say is I'm going to say that the vertex is 75, 25, right? And 75 is how many feet it is horizontally, right? So 75 feet horizontal. And 25 feet in the air. That's the max. So when it's 75 feet across, it's 25 feet high. You could have gotten 3 points for this answer, right? Identifying this, giving the context, 4 points, and drawing this. All right, it's not a hard problem. It just looks like a really hard problem because fractions always scare students. Again, you guys have a graphing calculator. Don't be afraid to use it, right? Again, also, right, this domain looks scary, but if you know the notation, you're going to be okay. So for the next 2 days, we're going to just practice these type of word problems where I'm going to ask you where it's increasing, where it's decreasing, if you can graph it over a certain interval. And that's it. All right. Thanks a lot, guys. I hope this was a good video. All right. Take care.